So good day everyone. So let me introduce myself. I am Sandy Arbaso and from BSMA 1C. So let's get started. So what is limit? A limit is the value that the function approaches as an input that approaches to some value. Suppose f of x is arbitrarily close to some particular finite value L as x is arbitrarily close to some value to a. Then we say L is the limit of f as x is approaches to a, and write this as wait for me. So this is the limit of f of x when x is approaches to a is equals to L. So limit has a theorem. So it has 9 theorems. So the first one is limit of c or constant. So limit c when x is approaches to a is equals to c. So c is for a constant. So if it is constant, so the answer will be also constant. Then for the theorem 2, limit of a single variable. So limit x when x is approaches to a is equals to a. So we substitute the value of x when it is approaches to a. So the answer is a. And for the third one is limit of constant and a function. So it is a combination of a constant and a function. So limit c of f of x is when x is approaches to a is equals to c limit of f of x is approaches to a. So we separate the constant from the function given. And for the theorem 4, so the sum of limit of 2 or more functions. So limit f of x plus g of x when x is approaches to a is equals to limit f of x plus limit g of x. So we distribute the limit when it is x is approaches to a. So limit f of x when it is approaches to a plus limit of g of x when it is approaches to a. Then the fifth is product of limit of 2 or more functions. So for this one, so we use product. So if limit of f of x multiplied by g of x when x is approaches to a, it is equals to we distribute the limit when it is x is approaches to a. So limit of f of x multiplied by limit g of x when it is approaches to a. So this is for the product of limit of 2 or more functions. So next is quotient of limit of two functions. So um, for this one, we have a numerator and denominator. So limit of f of x over g of x when x is approaches to a, we also distribute the limit when x is approaches to a, so it will become limit of f of x when x is approaches to a over limit of g of x when x is approaches to a. So provided the limit of the denominator is not 0. So we have a 4 reminders of for the theorem 6, which is the quotient of the limit of two functions. So if we let n is any number, so for the first one, 0 over n. So if ang final answer is mag-include na og 0, so 0 over n is equals to 0 or 0. And then 2, when n is over to 0, it is undefined or infinity. And for the third is n over infinity, the answer will be 0 or 0. And then for the fourth one, 0 over 0 is indeterminate. So this is a reminder for the quotient of the limit of two functions when we come up with the answer with a 0 or infinity. So for the 7, so radical of limit of function. So limit n root of f of x when x is approaches to a is equals to n root to limit of f of x when x is approaches to a. So this is the radical of limit of function. We distribute or putting the limit when x is approaches to a to the n root of f of x. Then for the theorem 8, power of limit of function. So limit when f of x to the power of n when x is approaches to a is equals to limit f of x when to the power of n when x is approaches to a. We also put the limit when x is approaches to a of the f of x to the power of n. And for the last theorem, for the theorem 9, limit of sine alpha over alpha as alpha approaches to 0. So limit sine alpha over alpha when alpha is approaches to 0, so it is become 1. So this is the answer with when sine alpha over alpha when alpha is approaches to 0, the answer is 1. So we will be given one example. For the example, so limit of x squared plus 3x minus 5 when x is approaches to 4 we will be distributing the limit when x is approaches to 4. So limit x squared plus limit 3x minus limit 5 when it is approaches to 4. And then we will be separating the constant from the function. And then for this one, for the 3x, we will be using theorem 3, which is limit of constant in a function when we will be separating the constant and a function. So for this one, we will be using theorem 8, and then for the 5, we will be using theorem 1, which limit of a constant, and we will be substituting the value when x is approaches to 4. So 4 squared plus 3 times 4 minus 5. So 4 times 4 is equals to 16, and 3 times 4 is equals to 12 minus 5, and then 16 plus 12 is 28 minus 5. So the final answer will be 23 for the 28 minus 5. So the answer will be 23. So that's will be all for the topic of limit. Thank you.